So good morning, everybody. I hope you can hear me well. We will start the meeting in a few seconds. We are just letting the people in. Okay, I think we have a lot of people already in. Let's start the webinar. Good morning again, everybody. My name is Myriam Bardají. I work at KIT, Karlsruhe Institute of Technology in Germany. And today I have the pleasure to moderate this webinar on behalf of the KIT coordination team, which title is Optimizing Grid Resilience, Exploring Hybrid Energy Storage and Artificial Intelligence Solutions. So can we go to the next slide? Let me start, give you some a general information on the technicalities. So as you can see here, the webinar will be recorded. And as we have a lot of participants online, you are not allowed to speak directly, but if you want to ask some questions, you can use the Q&A sections to make the questions to the speakers. And of course, the slides and the recording will be shared with the attendees after the event. So let's have a look into the agenda. We have closely 2 hours for the webinar today, as you can see here. We will start with a short overview into the StoRIES project, as well as a hybrid energy storage topic. And then we will have 2 different panel discussions. The first one will deal with hybrid energy storage system for grid applications, where we have the opportunity to have a look into 5 different projects, European projects working on hybrid energy storage. And then we will have a panel discussion. And then the second block will be dedicated to gaps and opportunities in AI-ready data for grid-scale storage technologies. So I think we have a very tight agenda. So without any further ado, I will give the word to Roberto Scipioni from Syntem, who is going to give the presentation of the StoRIES project and the roadmap that we are developing within this project. So Roberto, are you there?
Hi, Myriam, can you hear me?
Yes. So please go on.
Thank you very much, Myriam, for the presentation. Hello, everybody. I'm very glad to be here at this workshop today, and I'll give you a brief overview of what the StoRIES project is. This is a project, of course, where Myriam is the project manager and Professor Passerini from KIT is the coordinator of the project. And I will give you an overview why it is important to work on developing a better research infrastructure across Europe and why and the importance of the hybridization of energy storage. So thank you very much, Myriam. If we go to the next slide, we will have a brief overview and what is actually the actual context in Europe. And this is a very, we all know that recently also because of the of course, of the attack of Russia in Ukraine 2 years ago, and with the importance of tackling the climate crisis right now, recently the European Commission has presented the REPowerEU plan. This is a plan that has a lot of ambitions, like working on diversify energy supplies, working on energy saving, and also accelerate the deployment of renewable energies in order to replace fossil fuel in home industry and power generation. In order to tackle this, if we just move to the next slide, Myriam, we will have a look at, we have to, first of all, understand what the future energy systems will look like. And if we look at the future energy system, it will be decentralized, disaggregated, and multi-vector. Why is it multi-vector? Because we have a different type of energy carrier, and in order to enable the deployment of renewable energy sources, we need to focus on storage of energy, different type of storage. But as I mentioned before, being multi-vector, we will not have only one solution, like the holy grail of energy storage or holy grail of energy conversion, but we have to work and make all the solutions combine and work with each other. And we need so a flexible future energy system in order to achieve the objective of decarbonization, security, and affordability. So let's have a look at the structure, and unfortunately this has a lot of animation, Myriam, so I ask you to click at least once, yes, and two more, and we will have a look at the three main energy carriers that we're working with right now. So we know electricity, and of course production, power generation, and of course transmission and distribution of electricity in the grid, as well as fuels. And we are not talking only about fossil fuels, but of course biofuels or hydrogen or many other type of fuels that can be generated and transmitted into the grid, as well as heat and district heating. And all these three type of energy carriers. So when we look, and if you just click once more, Myriam, when we look at solution in front of the meter, we can provide energy that is before the meter, so like providing electricity into the grid that will be generated, for instance, by wind turbine, solar farms. And if you just click a couple of times more, Myriam, sorry, because there's any yes, application, just once more, and we will have a look at the full overview of applications. What we identify in the StoRIES project is we identify 5 larger type of applications from industrial grid or power generation, grid application, transmission and distribution, and off-grids and energy islands, that these are usually considered as front of the meter application. When we look at behind the meter, so like some smaller grid application, like when we talk about smart solution for mobility or smart buildings, or application also for transport, we also have to find the energy solution, energy storage solution that can store electricity, heat, or fuels that could be applied for transport or for like a home application or other commercial buildings application. If you go to the next slide, Myriam. We will then, as we mentioned before, we need to provide system flexibility, and the energy storage can provide this flexibility to absorb and manage the fluctuation from different type of energy sources. But unfortunately, there is no silver bullet solution, so hybridization is essential. And in the StoRIES project, we identified, and we've been working on developing a roadmap for hybridization of energy storage. And the main point was to, first of all, start giving a definition of what the hybridization term mean for energy storage. And we refer as the utilization of 2 or more energy storage technologies that can be hybridized and combined together at either the system, device, or material level in order to provide technical, economical, and also sustainability advantages beyond what the single energy technology can provide. So just if you can just click more. Yes, and so this is the main goal, as I mentioned to you before, of the StoRIES project. So identify the R&D needs for hybridization of energy storage, and this is something that will be presented, of course, in the roadmap. And of course, we want to enable breakthrough R&I innovation, research innovation across the whole value chain. So let's have a look at what the StoRIES project looks like. So the storage research infrastructure ecosystem, as I mentioned before, the coordinator is Professor Stefano Passerini, and we have a large number, of course, of partners and research infrastructure providers. As you can see here, this is a 4-year project starting in 2021 and will end at the end of 2025. We have 64 infrastructure all across Europe, and the 64 infrastructure are more for developing 5 different type of energy storage, from chemical to electrochemical, thermal, mechanical, and superconducting magnetic energy storage. And the idea is to foster this ecosystem of industry and research organization in order to cooperate and provide access to scientists, researchers, PhD students that want to apply for a research period in one of these 64 infrastructure. So if we just go to the next slide, Myriam. Yes, this is basically what we just mentioned to you right before. I just anticipated to you, and this is also one of the main objectives of the StoRIES project, and we will look at the next slide. Is to create a number of different outcomes that are key, important document, relevant document like the roadmap, that is a technology review for energy storage, the strategic research innovation agenda, and as well as we are working on creating summer school and master programs, the material acceleration platform to accelerate the development of material for energy storage, as well as you can see 6 transnational access calls. Right now, so far, 5 have been published, and this transnational access call provided funding for different researchers across Europe to have access to one of the 64 research infrastructure. And also, we are working on creating, of course, a white paper on sustainable hybrid energy storage, as well as a series of workshops for sustainable energy storage. So, and this is a structure of the group. So we have a number of different work package, and work package 1, that is the one working on creating this document, is divided in a number of working groups that each of them has a lot of experts that provide input to the roadmap and the strategic research innovation agenda, determine the calls, the topics for the transnational access call, and analyze the results from this research project, as well as defining technical and non-technical barriers for the development of hybrid systems. So let's have a look at the 2 main results or document that the StoRIES project is working right now, or 2 of the main results. And it's the roadmap and strategic research innovation agenda. Just to give you an overview and to avoid any confusion, just see the roadmap as a technology review that establish a set of needs that are relevant for energy storage in different type of application and at different level. And it works on listing and identify the hybrid solution and also the challenges for each of these 5 type of energy storage, from electrochemical, chemical, mechanical, and so on. And the main important point is to provide a forecast for the next 5 to 10 years. So the idea is to forecast what technology will be combined in the system in the short, medium, and long term. So this set the basis to identify what technology are needed to satisfy the requirement for hybrid energy storage. And this document provides the support for the publication of the strategic research innovation agenda, where this is more of a strategic document where we identify and we list all the current and all previous action taken by at the European level throughout the Horizon Europe work program, but also at the national level, try to identify which project have currently been funded to tackle research need in hybrid energy storage by the National Research Council or by Horizon Europe program. And then once identify what has been done so far, it start tackling what are the most important challenges and set the strategic research areas. That these are the most relevant area that need to be investigated further in the future to accelerate deployment of and support the development of hybrid energy storage solution. So let's have a look at how the 2 documents will look like. So to start, for the support of the roadmap and strategic research innovation agenda, this is the structure overall of the project, but the main work package that we'll be working on is work package 3 that provides services to the StoRIES project, and this in collaboration with work package 1, as I mentioned before. Most and directly connected with the working group 1 and 4, where the experts are external reviews that read the roadmap and SRIA, provide us input and support us with identify challenges and barriers. So let's have a look at the roadmap. As I mentioned to you before, this set I would call it like, I would say, the set the stage for developing hybrid energy storage. So they identify the different type of energy storage technologies that can be combined and suggest a viable solution to address the limitation of a single technology. And the five categories, as I mentioned to you before, are industrial, power generation, grid, off-grid, transport, and buildings. And so far, if you just go to the next slide. So far, this is the structure of the roadmap, where we, of course, we will present what is the current context, of course, what is, and as I mentioned to you before in the presentation, what the future European energy landscape will look like, trying to identify the energy storage needs for application front or behind the meter, and explaining what is the hybridization of energy storage. And the main core of the document is chapter 4, where we suggest a number of future hybrid applications for short, medium, long-term energy storage, as well as off-grid application. And the idea is to identify what are the best case studies for each of these applications. If you just click once more, yes, this is what I mentioned to you before. So thank you, Myriam. You can just go to the next slide, please. So we identify a variety of case studies that will be presented in each of the chapters for the 5 different type of application. And the final goal is to establish a clear definition and framework of the case studies, starting with identify, first of all, the technology neutral system requirements for the application, and how hybrid energy storage can meet this identified need. It's also very important to identify the drivers for installing the systems. In some cases, we could choose to go hybrid rather than a single technology, only because we want to increase the resiliency of the energy storage technology, or sometimes maybe the technical or economic advantage is not very well defined, but there is a very high advantages from a sustainability point of view. So we could have different drivers depending on the case studies. And the document will work on we will present a technical, economic, and sustainability analysis for each of the case studies. And last but not least, of course, it's important to define what is the current TRL of the technologies itself and in an hybrid system, and trying to identify challenges and what would be the time of deployment of implementation of such case studies. And then this is also something we're working right now in the document on the benchmarking and identify the key performance indicators. This is something that we already saw in many other roadmaps from other type of energy storage technologies. We saw this from either Hydrogen Europe or Batteries Europe or for Clean Aviation. Each of these, and there are so many other partnerships that I could list to you right now, and all of them work on identify the KPIs for each single technology. This is relatively easier for a single when we talk about one single technology, but what about an hybrid system? And an hybrid system could be hybridized at different levels, at both material level, device level, or system level, as we mentioned to you before. And this is the work that will be done by our expert in the StoRIES project in identify what are the most relevant KPI for each of the technology, and how this can be combined in order to identify and satisfy the final requirement of the hybrid systems. Okay, so the last chapter of the roadmap, as I showed you before, as also including a section on barriers and challenges. And the experts from Working Group 4 are working on identifying all the different challenges. They are divided into technical, socioeconomic, and legislative challenges. Of course, as you can read here from the list of bullet points, we could see that there are different challenges from starting, first of all, with the technology, maturity of the technology, so the different TRL level that we have between two technologies that need to be combined. but we could have socioeconomic challenges coming from either different electricity prices for each different country in Europe, for instance, as well as geographical dependency. We could have some countries, like for instance Norway, that could be more relevant for application of the gravitational energy storage with pump hydro, for instance, and this will be relatively complicated to do in some other type of countries that are a little bit more flat, differently from Norway. Or also some important legislative challenges. First of all, there is a lack of definition so far in Europe and standards for hybrid energy storage. And this is where the StoRIES project wants to actually start and defining what are the standards, as well as parts on identifying, defining new laws for taxation. This could be a problem when we combine two energy storage systems into an hybrid one, and we can find having problem with double taxation, for instance.
Roberto, please, can you speed up a little bit? We are running out of time there.
Yes. Yeah, absolutely. Please, then just go to the next slide. Yes, we are actually reaching very close to the end of this presentation. So, and as we mentioned before, right now we work on the roadmap that will provide a base for the SRIA. And the SRIA is a strategic document that identify all the action taken to address hybrid energy storage and set the strategic research area that have been not investigated so far. And if, yeah, you can just click 2-3 times more, and then we see what are the, yeah, sorry, once again. This is the structure right now of the SRIA. Of course, we identify the European framework and the policy agenda and see all the EU regulation that could be seen as an opportunity for developing hybrid energy storage. And so far, we identified 5 strategic areas. You can see here these are long duration energy storage. That is a hot topic so far right now, and this could be tackled by hybrid system. Also extending lifetime of generation equipment and hybrid system, integration of a multi-vector storage and conversion system, and digitalization with the development of energy management system. And last but not least, we need to set a regulatory framework for standardization of hybrid systems. So yes, so I just reached to the end of our presentation, and this is a final slide to show you how you can join the StoRIES ecosystem. Of course, for stakeholder, you can join the extended network, and for the single energy storage expert, we have a number of working groups, as you saw before, and you can choose to join and contribute to the documents or to the transnational access call, or you can join the selection panel. In order to do that, please contact StoRIES. You can see our ERA. You can see the emails here at the bottom. And also just one final slide that will take 1 second, Myriam. We know the StoRIES project is coordinating with many other energy storage initiatives. For example, we collaborated with Batteries Europe, and Batteries Europe has recently published a number of position paper on different topics like safety, sustainability, as well as digitalization and hybridization. And you can find here the link where you can download the position paper on hybridization of energy storage, where we from many experts from the StoRIES project have participated. With this, thank you very much for your time, and I'm open to any questions if there is time. Sorry for taking a little bit too long, and feel free to contact me directly, Myriam or Professor Passerini.
Exactly. Thank you very much for this comprehensive explanation on the roadmap and SRIA within the StoRIES project. We don't have time for questions, unfortunately, but if you want, you can just use the chat and write your questions there. We will try to answer. But since we are a bit late, I will go directly to the first block of today's webinar, where we will have the opportunity to have a look into 5 different projects working on hybrid energy storage. And I will give the floor now to our moderator of this panel session, who is Philippe Stevens, who is a senior scientist and advisor from EDF in France. I hope you are there, Philippe.
Yes, I'm there.
Okay.
Hello, everybody, and welcome. I'm Philippe Stevens. I'm a senior scientist at EDF, which is the French utility in France. So let's start straight away with our first presentation. We're going to have 5 presentations, very short presentations. We're running 10 minutes late already. So please keep it to 4 minutes so we have time for discussions afterwards. So our first presentation, so these 5 presentations are on hybrid energy storage for grid applications. And our first presentation will be made by Gianluca Lipari from EPRI in Ireland, and it will be the Agustin project. Please, Gianluca.
Yes, thanks, Philippe, and good morning, everyone, also from my side. Yes, I will try to be super brief. In the next slide, we have the Agustin project. Yeah, in a nutshell, what we are doing in our project is focusing on industrial use cases and applications, and what we want to do is to simplify and speed up the deployment of renewables thanks to the integration of innovative storage solutions. We started in January 2023. We're going for 4 years. These are numbers we're not relevant, so we can go to the next slide and focus on the objectives. We have 6 main objectives. As I said, we start from understanding what are the performances and the added value of storage for industrial users. And we also want to define and implement what we call an advanced grid interface, AGI, which is meant for the integration of renewables on site with the industrial process and the local generation. We look into different form of storage. I will have something in the coming slides. And also, apart from optimizing the industrial process, we also look into providing grid services and also, let's say, help the energy transition. We also look in understanding what are the emissions that we can reduce or the use of material by optimizing the integration of storage and renewables. And of course, we look into what are the business models that can sustain our solutions. In the next slide, we have what I just said, this central component of Agustin, this advanced grid interface, which is an interface, a DC common bus, where we integrate the local generation, for example, from PV, the different industrial loads that we have in our demo site, and the different storage solutions. So we integrate different assets. We, of course, integrate also not only physically them, but in the control and optimization strategy to provide, as I said before, grid services, but also optimize the usage of resources within the industrial premises. And the idea is to have an interface that can be flexibly extended or improved by, for example, integrating new type of storage or additional generation or extending the industrial capabilities. If you go to the next slide, we are looking at different technologies for storage, energy storage. We have a specific type of aqueous electrorecuperators, which are something, if you want to say it, simplified, in between lithium-ion batteries and supercaps. So with quite interesting dynamic behavior that is relevant for one of our use case on green hydrogen production. We are looking into redox flow batteries in one demo site, and also the usage of an existing irrigation system and the pumping loads as longer-term storage within the demo site. In the next slide, instead, I'm presenting the 2 main demo campaigns we have. The one on the left is on green hydrogen production in the Netherlands with Shell. And the one on the right is what I just mentioned on the irrigation system in Spain with the infrastructures. And if you go to the next slide, we can see just quick facts about both of them. The first one is the green hydrogen. So there is a Shell facility in the Netherlands that is designed for green hydrogen production. The facility is meant for producing via electrolyzer green hydrogen, of course, as local renewable generation. And also there are some limitations from the grid operator on the injection into the grid. It's limited, actually, the site shouldn't inject into the grid. So that's one of the constraints we have. We also have the constraints related to the transient of the electrolyzer and the renewable generation that need to be dynamically controlled. And what we are looking at is using the storage to somehow keep the limitation on the injection to the grid imposed by the grid operator, but also provide some flexibility to the grid in a second stage. In the next slide, instead, we have some facts about the irrigation canal demonstrator, which is placed in Segria Sud in Spain, in Catalonia. It has almost 17 megawatt of loads, so most of them pumping loads. There is local generation and a huge yearly demand, which is quite seasonal also. The total energy demand is also the biggest chunk of the operational cost of the community. So one of the objectives here is to understand how we can optimize the usage of resources depending on the season, depending on the peak load or peak generation, and provide reduction in cost to the irrigation community. We also look into the usage of the irrigation canals, especially during, for example, spring or autumn, using them as a long-term storage and be ready for the summer period where the demand increases. And the final objective is to combine the storage, different sort of storage, both long-term and the short-term, and improve the business of the sustainability of the whole irrigation facility. And that was, I believe, my last slide. I hope, yeah, that's it from my side. I guess we can answer questions later on, and I will be happy to.
Thank you very much, Gianluca. Very interesting demonstration of how these different technologies can be hybridized. Just a reminder that if you have questions, please use the Q&A part, and then we will answer all these questions during the panel discussion. So our next project will can somebody please could you cut your microphone? Our next speaker, yes, our next speaker is Zafer, who's a founder and managing director of PCM Products in the UK, and he will be presenting the ECHO project.
Good morning, everyone. And our project basically is the UK-wide as well as the European-wide developments of a new technology whereby storing the energy in the form of thermal energy storage and providing heating and cooling for the domestic applications. We have various participants, and it's, as you can see on the map, it's a 4 years project and total funding roughly 8.2 million. And various partners, as you can see, the list of is extensive, 17 partners. And next, to describe the project slightly, what is involved, can we go to the next slide? Or there's a simple video we prepared for you to explain the project. It stopped.
To reach a net zero greenhouse gases, GHG's emissions economy by 2050. Energy storage is a key factor in this green transition. The actual market of energy storage systems is mainly focused on electricity storage solutions, with consequences in terms of availability, costs, and environmental impact. ECHO is a European project with the aim to develop an alternative system exploiting thermal energy storage (TES) solutions. ECHO will be compact, flexible, modular, plug-and-play, sustainable, and digitally controlled. TES solutions are based on the optimization of thermochemical materials, TCMs, combined with phase change materials, PCMs, for space heating and cooling, hot tap water production, and ice storage. ECHO will be feasible to be charged in different ways, exploiting the electricity overproduction from the grid, directly connecting to renewable energy sources installed in the building. Electrical energy can be converted in thermal energy by means of a heat pump. ecosystem will be designed for different energetic scenarios and different scales, from small apartments to larger buildings. The project results will be validated in a first lab prototype and then in 3 different demo sites in Italy, Serbia and Belgium. Meanwhile, in the cities of Bilbao and Valencia, the operation of widely diffused TES systems will be simulated at city level. Impact and potentialities of eco-technologies at a large scale will be tested with an agent-based transaction simulation system, ECO-TSS, to define how individual small-scale systems could operate synchronically in different markets. ECO will demonstrate the sustainability of TES solutions in terms of abatement of greenhouse gases emissions, energy peak load shaving, and costs avoidance in the residential sector. This project will even contribute to the awareness of EU citizens and policy bodies about the positive implications of TES, and to investigate and solve constraints for the penetration of such technologies on the mid to long term.
One of the significant advantages of this technology, it's being a modular, and also, of course, the thermal energy storage, the combination of one of the unique part is combining thermochemical, phase change material, and ice storage in a single unit, enable to heat pump to operate both summer and winter condition, providing heating and cooling, and also connecting into the grid, which the grid can manage to operate this system. And when there is a surplus energy, which is one of the biggest problem at the moment, wasting a lot of wind and solar energy, which is not in use, and that basically will give the grid the facility, all that surplus energy available during sunny days and windy days, put into these systems and distribute throughout the country, and therefore stabilize the grid. And we basically has 3 real installation to monitor the operation of the system. And hopefully, fingers crossed, we will be basically managing a reasonable size and also within the cost restraints of the economics. And that's about it, I think, is my 5 minutes. Thank you.
Thank you very much, Zafer. A nice demonstration of how to combine different thermal energy storage. Our next speaker is Virginia Ruiz, who's a senior researcher at University of Borrás in Spain, and she'll be presenting a new type of redox flow battery, the Me battery.
Okay, thank you. Can you hear me? Yes.
A bit louder. You're very faint.
Okay. I'll try to speak louder. Okay, my name is Virginia Ruiz. I belong to the University of Burgos, to the project coordinator team, and I'm going to present the mediated biphasic battery project. That is, next slide, please. It's actually a Pathfinder open project, which means that is for more fundamental technologies, radically new technologies. I'm seeing here a message. Okay. Yeah, it started in 2022 and will last 3.5 years, and it has a budget of 2.5 million euros. We are 6 partners, so it's a smaller consortium, and as the idea is at the end of the project to have a prototype working at TRL4, so a demonstration. We coordinated from the University of Burgos. We have as partners Indea Energy in Madrid, Universidad de Aveiro in Portugal, Bochum University at Germany, StoRIES at Germany as well, and the Institute of Science and Technology in Austria. Next one, please. So the overall objective of Me Battery is to lay the foundations of a next generation battery technology that overcomes critical limitations of state-of-the-art batteries, mainly static batteries like sodium and lithium ion, but also redox flow batteries like all vanadium and zinc bromide. Especially, we want to overcome limitations such as sustainability, cycle life, recyclability, eco-friendliness, cost, temperature range of operation, and safety, thus offering an excellent balance over all key performance indicators. Next one, please. So how we want to do that? We want to upgrade redox flow batteries, which we believe is a very promising technology. I mean, with its special configuration where energy is stored in liquids in external tanks outside the electrochemical reactor that are pumped to deliver power on demand. This special configuration allows a lot of flexibility because energy and power can be separately scalable. Especially we focus on aqueous organic redox flow batteries because we want to have this component of environmentally friendliness. And thus, they have excellent features for the grid resilience and reliability, such as long calendar life with excellent cycle ability. They are suitable for long-term storage. They have very fast response time. They are tolerant to deep discharges. They have low maintenance costs, low self-discharge, and they can be easily recycled or repurposed, just refilling or replacing the electrolytes. Thus, they are very suitable for integration of renewables to the grid, for micro and smart grids, and grid stabilization. Next one, please. However, despite their promise, there are some room for improvement. There are some limitations of redox flow batteries. One is that they provide very low energy density that is given by the solubility of active species in the tanks. And second, they require expensive ion selective membranes to separate both electrolytes for the positive and negative compartment, which are costly. In the end, there are some crossover of species across the membrane, leading to a lower cycle life. And then they have some environmental impact because they are naphthion-based, they are perfluorinated alkylated substances. Next slide. So with these limitations, our technology, the mediated biphasic battery, wants to tackle these issues. One, the issue of low energy density is by storing energy in solid materials in the tanks, while this special feature of redox flow batteries, the decoupled energy and power, is preserved, and we increase, because of course solid materials have much higher volumetric energy density than liquids, whereas here the liquids, the electrolytes, behave as redox wires, as molecular wires conveying energy from the solid active materials in the reservoirs, in the tanks, to the electrochemical reactor. And the second innovation is removing the ion selective membrane, the costly ion selective membrane, by confining the active species to immiscible electrolytes. That way, we remove the PFAS environmentally concerned membrane, and with lower costs. And for that, we are relying on fundamental science. We're mastering the interfaces, thermodynamic and kinetic processes at solid liquid and liquid-liquid interfaces. Next one. And yeah, if you want to know more about the project, I invite you to visit our website, where there's a nice video, as the one that was presented by the previous speaker, explain more in details the concept. And you have some questions, you can ask them. I will be glad to take them. That's all. Thank you.
Thank you very much, Virginia. Nice demonstration of hybridization in a redox flow battery. So please go to the Q&A part for your questions. Our next speaker will be Cristina Prieto Rios, who is a scientific advisor at the University of Sevilla in Spain, and she will be presenting the Hybrid Plus project.
Thank you very much. Can you hear me?
Yes.
Okay, perfect. Thank you for the invitation. I'm going to present the Hybrid Plus project. It's a project for the advanced hybrid solar plant with phase change material storage solution in supercritical CO2 cycles. Next one, please. Basically, this project has 7 partners: the University of Seville, we are the coordinator, the University of Lleida in Spain, and the KTH Royal Institute in Sweden. And for SIME, Seco, that is a small company for heater design, Build to Zero, and a small company here in Spain for storage product, R2M for dissemination, and Stack that offer metal goods. Basically, this project has a budget of 2 million, well, near 3 million. It's a RIA, so 100% funded. The project started in December 2022, and we will finish in November 2026. The duration will be 48 months, and the main target is to demonstrate an electrified thermal energy storage system based on phase change material in a cascade configuration for the next generation of hybrid CSP plant with advanced supercritical CO2 power cycle. Next one, please. The idea of this project started trying to reduce the cost of the concentrated solar plant that use Rankine cycle and work with molten salt at 565 degrees. In order to increase this efficiency in the cycle and reduce the cost of this technology, there are a lot of development that work with a supercritical CO2 cycle that work at higher temperature and at higher efficiency. But if we work at temperature higher than 600 degrees, and in this project, the target is 610 degrees, the main problem with the current molten salt is the degradation, mainly if this temperature has high residence time. And this is the reason why we are going to use this molten salt only as heat transfer media, while we use or we design a new indirect storage system with phase change material in order to reduce the residence time at this high temperature. And we create, as you see the figures in the left side, we can see the different cascade of phase change material that we are going to implement in order to charge and discharge with a very high round trip efficiency. Next one, please. Sorry. Yes. So this cascade has a configuration per module where we will design a heat exchanger where the heat transfer fluid will go through the tubes and the storage media will be on shell side. If we use PCN, the thermal conductivity of this material, usually we are going to use a different salt, mixture of salt. This thermal conductivity is very low and is a limitation for charge and discharge processes. And this is the reason why we need to increase this thermal conductivity. There are, in the state of the art, several technology to increase this thermal conductivity with fins, with foams, but we have chosen the use of metal goods, recycled metal goods, in order to reduce the cost with this material that will increase the thermal efficiency, the effective thermal efficiency of the composite, the mixture between metal wool and the salt that act as a phase change material. And with this configuration that can be charged and discharged thermally, the idea is the hybridization of this concept with a direct electrification. So if we can electrify directly this metal wool, we can hybridize this configuration with energy coming from the grid or from PV or from any renewable source. Next one, please. So this development with the different PCN modules and the different electrification concept, we are going to test 3 electrification mechanisms: immersion heater as the more mature solution, ohmic heating as an induction heating as the 2 most innovative solutions. The 3 mechanisms will be tested in the experimental platform that we are going to install here in the University of Seville, with a capacity of 100 kilowatts of storage that will work with molten salt at up to 610 degrees, ready to validate any PCN cascade and even to validate sensible heat if needed, with some capacity for electrification around 120 kilowatts. Next one, please. And this product will be used in the current state-of-the-art CSP plant. With the current seed turbine, we can replace the molten salt direct storage system with this more compact, high and more and cheaper solution with this cascade of PCN. This solution can be also implemented in the supercritical CO2 cycle, working at 610 degrees for the new design or the next generation of CSP plant with high efficiency. And in addition, this solution can be used for process heat. process heat with a solar field to reach a heat-to-heat solution, and with an hybridization with PV or wind or any or directly from the grid for a power-to-heat solution. And in addition, we can use this e-test solution with this PCM cascade as a product itself connected directly to the grid. And this is very relevant because the footprint of this solution is very, very, very small, and it make easier the implementation in the industrial that has usually a limitation related to the use of land. Next one, please. So at conclusion, the Hybrid Plus is focused in a new configuration of high efficiency CSP plant with a novel storage product for power to heat to power or power to heat solution. The product is based on a new cascade concept that use phase change material with recycled metal goods to enhance conductivity that can be hybridized with electrification. This solution has application in CSP, in process heat, or as a e-test product itself. The Hybrid Plus will include an experimental platform for the validation of e-test storage solution up to 600 degrees at relevant scale. Next one, please. Here you can see our presence in the media. I have add in the chat the video link. Next one, please. And this is my email if you need more information or if you have any question. Anyway, I will be here to answer any question that you can put in the chat. Thank you very much.
Thank you very much, Cristina, for this nice demonstration of different materials and different technologies for concentrated solar power. So our next speaker is a man called Borrás Morrison, who is Innovation PMO Manager at IDP in Spain. And he'll be presenting the Hybris project. Please, Mike.
Yep. Hello, everyone. Thanks for the opportunity. So I'll try to be fast and stick to the 4-5 minutes. So let's move on to the next slide. Hybris project basically aims at improving. So basically aims at what you can see here, but the backbone is the integration of two different battery technologies. So move on to the next one. One of the batteries is this commercially available lithium titanate, and the other one is an innovative aqueous organic redox flow battery. Okay, so while we move on to the next slide, this coupling, this integration of two batteries is backed by a breakthrough advanced battery management system, a novel power electronics, and also a power management system, all fully integrated with an EMS. Okay, apart from that, we have other technologies such as a hardware in the loop based digital twin that helps us optimize the sizing of the battery system aimed at the different services and different demo site needs. Move on to the next one. These are the different impacts goals we seek with Hybris project. Okay, with kind of a reduction of the capital expenditure, operational expenditure, and above all, I would underline stress these energy storage costs below the 0.05 euros per kilowatt hour per cycle by 2030. Let's move on to the next slide. This is a kind of a presentation of the consortium overall. It was a 3-year project, but now it was extended, so it was meant to finish by the end of 2023, and it will end December this year. It's 15 partners and 3 different demo sites. Move on to the next slide, please. These 3 demo sites have different goals and a different. One is a residential and commercial site. This is like the residential side is in Italy, and the commercial and offices side is in Belgium. And there's also another site that's kind of allows to replication potential in the Netherlands. Let's move on to the next slide, please. The first site where we are implementing this HES system that, by the way, it will be containerized. So we are producing this HES container and shipping it from Spain, where it's assembled. And firstly, we are shipping it to Messina. This is a residential energy community. And one of these services or the goals that are most interesting for this HES is the island mode. And this gives way to my next two slides that basically, the idea here is to present the different services, or in other words, how we intend to improve the grid with this HES and the different services. So you can see here different services that we are aiming to provide the end users and the demo site owners. So one is the community demand response, where we intend to minimize the occurrence. The other one is the safety reduction. So we intend to have a 100% reduction on frequency interruptions, etc. The other one I already mentioned, and this gives way to the two next services, is the island operation and the grid forming. So we intend to have no interruptions of the grid service in Messina and no outages detected. Next slide, please. The other services are these peak shaving. This is really interesting for the Belgian and Netherlands sides. This was the main interest by the demo site owners in Belgium, where they have a lot of peak problems. Also, to increase the self-consumed energy. In Belgium, we intend to have an increase more or less around 75% of the consumption of self-produced energy. And finally, these other three services: arbitrage, FCR, and energy community. When energy community, we mean to basically be able to share the energy with either businesses that are nearby or households in the energy community. And I think that with these slides, I will be finished. So yeah, any questions, comments, just I'll be happy to answer. Thank you.
Thank you very much, Michael. So let's jump straight to our Q&A and panel discussion, because we have limited time. And maybe I can start with Michael, since you're still with the first question. Maybe can you give us maybe your view on the main challenges faced when integrating two different storage technologies at a system level?
So yeah, sure. So for example, the challenges we are facing in our case, it's on the one hand that we have experts with the lithium titanate battery, obviously, but then when it comes with the aqueous redox flow, it's very complex to the integrators we have at hand, and it's a really specific and complex technology. And in addition, it has chemicals which raise security and safety issues that need to be taken into account, and that sometimes they do not necessarily they are not necessarily under control, but by the integrators. So this means that, this has meant that the technology owners have to need to have a really important and proactive role when it comes to the integration. On the other hand, we have also found a problem that it's really physical in the sense that the aqueous redox flow has a huge amount of liquid, of electrolytes, that rises to more or less 7 to 8 tons. Okay, so that obviously means that when handling this huge amount of liquid, well, certain actions need to be taken into account. And then, most importantly, now that we are facing the shipment of the HES container from Spain to Italy, it has logistical problems. And for example, we have had to do 2 different shipments, one with the HES container without the electrolytes that go separately. And I think that probably summarizes kind of really well the problems that we have found so far in this regard.
Thank you. Maybe a question to Gianluca. Gianluca, do you see any limitations or policies that limit the integration of hybrid energy storage onto the grid? And if so, how can they be improved?
I was muted. Thanks for the question. I think it came out also in the other presentations that it's a recurring theme. There are, of course, the technical solutions, the technical requirements that are challenging, but also what is the regulatory landscape is in some cases could be limiting or could be slowing down adoption of specific configuration or storage solutions. In our project, for example, what we see is that depending on the type of assets we want to integrate, they fall within different parts of the grid connection codes. So it's not always easy to merge them together, put them together in the same site, which also has effect on what are the investments needed because you need to meet different requirements for different assets. There is, however, revisions or discussions on how to update the grid connection codes, and that's a good point. I believe it's getting momentum, and there is a draft right now that addresses some of these challenges. What we are doing in Agestin, at least, and I think I got some insight of similar solutions also in the other projects, is when you want to aggregate different type of assets or different type of storage technologies, and maybe also provide different services. Depending on how you see or you design your point of connection to the grid, maybe you can satisfy some requirements or multiple requirements with the single connection point, maybe with the controllable single converter, and that, at least in our case, it's simplifying and speeding up somehow the demonstration that we want to implement. It's one step. It's one. I don't want to call it workaround, but it's one technical solution that helps in this respect. But as it was said also at the very beginning, there is a little bit more on unifying, standardizing the requirements and the needs also from the regulation point of view.
Thank you. A question to Cristina. Maybe can you give us some insight to how thermal energy storage contributes to grid stability?
Well, as I have mentioned, the Hybrid Plus is developing this electrothermal energy storage for CSP plant, but this ETS can be used as a product itself. And one of the benefits is that this system utilize the renewable electricity during a period of high solar and wind generation. So we are able to reduce the curtailment levels. And in addition, with the direct electrification, we can offer flexibility services. And this is very, very useful in order to do this stabilization. Take into account that the charge of this ET system and the discharge are completely decoupled. So the charge can be done when the grid needs this service. And can do it because the charge is very fast. This electrification is very fast. So the answer from this e-test configuration can cover a range of time that in the past other thermal energy storage configuration were not able, because we have certain thermal inerts to prepare this thermal charge. And this product will have a massive implementation, or could have a massive implementation in the industrial heat. And that means that this is a solution for the new market renewable penetration that will be needed, because the new ETS configuration that we are designing is very simple. It's compact, it's modular, and can be standard, and can be applied, for example, for process heat with low capacity. That means that we can design big solution for CSP plant hybridized with PV, or can be used for small plant, 5 megawatt thermal for process heat. And why this is an advantage? Because for electrification, in Spain, for example, we have a very handicap related to connection to the grid. And we have some limitation with this connection. If we reduce the power in this connection, for example, for 2.5 megawatt, the number of grid point of the grid connection that we can install can be multiplied. And the use of this solution in the process heat market can be multiplied. And finally, the solution in flexibility that this new product can offer will be multiplied. So at the end, will be a key player in the stabilization of the grid due to the massive implementation foreseen, and the high flexibility services that can offer at very low cost with very high round trip efficiency in power to heat.
Thank you. Thank you. One question for Virginia. Maybe can you give us the main challenges and limitations that your redox flow battery is trying to address, and maybe a subsidiary question: how can you avoid using these very expensive ion exchange membranes, perforated membranes in your technology?
Well, these are two questions, right?
Well,
First,
yes.
So
Sure.
challenges and
Answers,
limitations.
please.
Okay, challenges. Well, I think I already explained it in my presentation, and as Mikel has explained, I mean, the problems with aqueous organic redox flow batteries is the volumetric capacity of liquids. So that's why we're working on storing the energy in solid materials, because theoretically we can increase 2 orders of magnitude the volumetric capacity of redox flow batteries. So that's one of our main drivers. And also the environmental aspect. I mean, the state-of-the-art vanadium redox flow batteries uses vanadium. That is a critical raw material working in strongly acidic conditions. So in the case of a leakage, well, we wouldn't like to have the very strongly corrosive electrolyte spill out. So what we are actually focusing, we have a work package addressing especially environmental impact of the developed materials. So main driver is to tackle the safety, especially the safety of the liquid electrolytes. So we're focusing not only on earth-abundant feedstock precursors for our electrolytes, but also that they are safe. So sustainability and safety. Then the second question was, sorry. So that was what we're trying to face, challenges.
Yeah, the second question was, you said in your battery you don't need to use expensive perfluorinated membranes. How do you manage not to be able to use those? Not to have to use those?
That's actually very challenging, and that's the thing that is being more difficult. But we're relying on very valuable expertise from a partner, the University of Aveiro and Imdea Energy, who have already demonstrated that it's possible to produce membrane-free redox flow batteries. We are relying on some concepts from the field of extraction and separation processes, where, I mean, they have even using modeling to identify suitable, we're not talking about organic aqueous interfaces, it's both aqueous. So it's possible by selectively designing the redox mediators to confine them in these immiscible liquid electrolytes. There, of course, you can do it, but then the challenge is once they are charged to avoid the self-discharge at the interface. So that's proving to be very, very, very difficult. But yeah, I mean, as we said, this is not a high TRL project. This is for new disruptive concepts, and that's the main innovation. Apart from the redox mediator concept of storing energy in solid materials and finding suitable electrolytes to transfer charge reversible with the solid materials, then confining them selectively in each of the two compartments, in each of the two liquid electrolytes, without self-discharging at the interface. So we're working on that. We have also applied for a 6-year extension because, yeah, it's proving very, very challenging, but we hope we will do it.
And just a very quick answer from the chat. We have a question asking what the energy density you expect. I know it's difficult to say right now, but do you expect an improvement in energy density in terms of kilowatt hour per meter cube, for example, with your redox flow and redox target redox mediator system?
Sorry, say again.
By using this redox target energy storage hybrid system, what do you expect in terms of improved energy density?
Well, our objective in the proposal, it was simply to reach around 50 watt-hour per liter. We're talking about volumetric. But the group already has proven and has reported 100 watt-hour per liter. Practical, but theoretically, we believe we can reach around 300 watt-hour per liter, which would start to be competitive. But as I said, our main driver is especially the safety and environmental aspects. I mean, while being also competitive in terms of energy density. Yeah.
Impressive. Thank you.
You're welcome.
Do we have time for one last question, Myriam?
Yes, I think we can have 2 or 3 questions. So 2 more minutes.
Yeah, and maybe a question to Zafer, if you're still there. I can see your
camera. Yep.
Yes, you can. So maybe Zafer, can you tell us why it's important to smooth the production curve and how can hybrid energy storage help in smoothing this curve?
Okay. I think it's one of the main problem at the moment what we are facing, the extent of solar and wind energy. And 10 years ago, we had more or less none. But now is we basically subsidize and screw the electricity generation and the grid pretty badly because it's a good idea to have solar and the wind. But what happens when they generate awful lot of energy, which we still need the baseline, nuclear, hydro, and other plants, and we have an incredible surplus of energy. Nobody wants to use it. And in fact, some of the countries like northern Scandinavian countries start paying people to use electricity. So therefore, there is a time in the grid we have excessive, massive free energy available, but nobody wants to use it. There is nowhere to use it. And 6 hours later, there is a massive demand and we are struggling to supply power using all the gas, diesel, you name it, anything else we can call, certain countries like Germany, and using coal now, and to give that power. So therefore, there is a gap between the energy availability and energy use. Hence, the thermal storage is a vital part of one of the solutions to store as much as we can while the energy is available and bridge the gap when the energy is needed. And that thermal storage probably is the most economical way to bridge that gap as it stands, because of the short, the life of the batteries and the replacement costs over 25, 30 years, as supposed to be a static systems on thermal storage, which life is forever. And therefore, it offers an economic solution to one of these current basically dilemma we are facing. And that is the crucial, but also with part of our eco project, which we are trying to bring it down to the basically individual application levels, to be able to these thermal storage system communicate with each other as well as communicate with the main power supply network so that the network can decide where to divert the power and store the energy when it's available. And accordingly, basically, instead of going up and down, and in fact, I don't know, have any of you heard about this new funny phrase came as duck curve, and it's a bit like a duck shape at the back of it. So, instead of having like a wavy power generation and the demand, if you have a rectangular flat profile, that is the best option. That means we need less coal, gas, and any other, basically, the power generation, and maximize the use of free energy, either solar and wind, and use the baseline, whatever we prefer, whether nuclear, hydro, anything else. And therefore, really, the thermal storage integration with the grid is vital, and I think that's the way forward for the future. Thank you.
Thank you, Zafer. I see Malek's waiting patiently there for the next session. So I'd like to thank all of the speakers from this first session, and hand over to Myriam and Malek for the next session.
Also, thank you from my side, and thank you to you, Philippe, for the moderation of this interesting panel. Then we can move to the second block of today's webinar, and I will give the word to Kourosh Malek, who will moderate the second part dealing with artificial intelligence and grid-scale storage technologies. And Kourosh, are you there?
Yes, can you hear me?
Okay, great. Yes, very good.
Okay, so I'm just going to get to a few introduction how we're going to run this panel. A little bit different format than what we had in the first part, while I'm expecting that to get access to share my slides as well. So essentially what we're going to do in this panel, responding to the needs of data management, as well as leveraging advancements in AI driven approaches to make a better sort of impact of the data that is coming from energy storage system, and how that would help sort of accelerate the hybridization. The way we're going to run it, I give a little bit of opening remarks of some challenges and questions. Hopefully that would open up thinking with audience, and hopefully we get some questions there, and then I go right away to our distinguished panel members who are going to address a few of the key questions. And then at the end, I want to really give 10 to 15 minutes to audience to come back to all the questions that comes out of all these discussions. So what I'm going to do, let's see if I can share my slides. Just starting from a few of these remarks. Okay, great. So very quickly, I don't intend to set any note or any sort of tone here. Just bringing some of the challenges that we have on the data side and the grid scale technologies in general, and the storage in specific. So one of the things that we all agree on, and I think there is no argument around it, is acceleration is needed on transforming to new energy era due to several factors. What we used to call 1C in the past, that were very much focusing on the technology and on a cost, performance, and durability, is expanding into circularity, supply chain, criticality of the components and materials, as well as devices. And if you look at multi-sectors, automotive, and also energy production, as well as renewable fuel productions, there are accelerations needed sort of happening in the R&D side for the materials, as well as for the devices and components. When it comes to energy storage, the problem are twofold. We're dealing, as you saw in the first part, and also the talk on the roadmap given by Roberto in the beginning, is that we're dealing with a sector that has many solutions in the market, about 12 to 15, on different disciplines, all from chemical, electrochemical, thermal, and so on. That's one part of the problem. And the other part of the problem is that we're dealing with a system that is not really commercialized yet. It's at best at the early commercialization or pilot, or mainly demonstration stage. So that's basically brings a lot of complexity in terms of the targeted services monetization strategies, business models that makes the sort of the role of data extremely important at this stage that technologies. And that's why we always say no energy storage is able by itself meets all the application requirements. So data in RD&D is important, and I think we all might agree on the sort of level of data that is available. What is difficult is managing of those data, and it's very resource intensive. There is a disconnect between systems of operating of these technologies and sources of data and labs that are developing components and materials and cells and devices. And of course, nobody wants to get into that unless all the data is available and cleanly sort of offered. But there's also, in addition to the technology development, there's also a sort of economic value added to this, and that's why I think sooner we can get into solving this problem on data, especially with advancement on the Gen AI, that it's happening all over across enterprise solutions on big data. Adding all that into is important. So two points here. The interoperability, of course, is important. We have to make sure it integrates into the workflow, and it's also able to look at all the requirements of the user data in terms of security, enrichment, and insights that is required. And the second is that how we can put AI really in practice so that there is advancement in terms of the delta of the cost of operating of the systems across different sectors on the grid storage. So with that, I want to get into some key sort of keywords, key points and keywords that I want to point out here. Ontologies. Of course, we have to look at ontologies in this sector that is able to go all the way from vendors and technologies all the way up to the installation, operation, decommissioning, and recycling. The role of sort of transparency on the metadata and standards and fairness of data. Technical data is combined with economics, operational market data in this sector. As we discussed, we're dealing with the service as well as the economics of the technology itself. It's very sort of interrelated in terms of the data structure, and the format of the data is anything from a batch to real time. And that's one of the aspects that hopefully we can answer some of that in this discussion. So without any further ado, I want to introduce our panel members that are joining me in this block. Massimo Celino is from Enel. He's a research scientist. I give a little bit of time, 1 or 2 minutes, to each of the panel members to add into their affiliation and to their focus related to data, so that the audience are more familiar with their activity. Diego Arnone is also head of a smart energy project involving IoT activities, as well as some other areas of research at ENG. And also from KIT, we have Benjamin Schäfer from the department as tenure track professor, as well as managing and leading a young investigator group focusing on different aspects of the hydrogen as well as grid scale storage. So I want to start with Massimo, if you want to add anything into his affiliation and his current and past work on data, only 1 or 2 minutes before we get into sort of heavy Q&A to start our conversations. Massimo, please.
Okay. Thank you very much for this presentation, for this opportunity. Just want to point out some key issues in data management, because data are very crucial in all these aspects of energy storage, research, and community. So we have to have a clear in mind that the benefits that we have investing in data, in real data management. So for what concern materials discovery, optimization of energy storage systems, predictive modeling, and the use of artificial intelligence for this research. We can face safety and reliability also by exploiting data. And also, last but not least, the integration of this research in the renewable energy sector. So we can, moreover, there are some hints how to share the data. In StoRIES project, we have developed some common steps, some steps that are needed for this. For example, to create centralized data repositories, or we can use cloud storages or data spaces. We have to develop data standards, ontologies, and taxonomies. For example, we are discussing a lot of this aspect in the StoRIES project. And also to develop a common infrastructure, a technological infrastructure for this, for the community. So, for example, to have a common API, user-friendly interfaces, so to have easy share and data upload, access, integration. If everything is done and there is really the idea to share the data and to exploit them, we can move further. For example, there are new trends in the artificial intelligence that are very interesting to be exploited. For example, there are what are called the foundation models. It means that you have to choose the right model that is already developed with a large sets of data, and then we can optimize for the energy storage community. Or there are other approaches, for example, federated learning. So in each site, we can develop artificial intelligence models, and then we can share the models and optimize for properties, usage that are of common interest in the energy storage community. So there is a lot of work to go beyond to exploit really the data sharing.
Okay, thanks. So I'm just going to stop sharing. Going to thanks, Massimo. You have pointed out a lot of important things that right aligned with what we want to discuss on the first part of the discussion. I want to make sure I also refer to all your work and affiliations and work. So if you answer any question, I appreciate you also allude to that if anything missed in my introduction. So I want to build on what discussed in Massimo. I'll come back to you, Massimo, with some aspects of the acceleration again. But one of the things on the acceleration side is that a lot is happening on the materials, and a lot should happen also on the technology itself. I want to open up this discussion. Maybe I go to Benjamin to follow up on that. Is that the acceleration has to happen, but what has to happen? So what are the part of the value chain has most potential for acceleration from materials all the way to the devices and systems? And what are we on that in hydrogen and energy storage technologies in general? Please.
Yeah, thanks. So I would maybe also complement my introduction very quickly in that I am actually more of a, let's say, data user and machine learning trainer. So I'm more on the later side of already the data pipeline. So I think all the points that Massimo mentioned of data standards ontologies is extremely important for the perspective of actually training any AI models. And I mean, my expertise lies a bit more on the grid side of the power system implementation, so more on the electrical side of the grid itself, and not with the main focus on the storage systems, except for example, optimization, reinforcement learning of individual systems. Then, so what you're saying there, I think, is it's really important that we work for data standards, and I think this idea of having like a central data hub where the data is available also from different initiatives. I think we have seen like lots of interesting projects being presented in the first panel. I think it's really critical that this is being collected, because otherwise, if we don't agree on where we put the data and how we put the data there, it's going to be extremely difficult to train anything like a foundation model, for example, that tries to implement several of these aspects. So, but I don't know whether I really addressed the question you were asking there.
Yeah, no, absolutely. I just want to get a little bit more focus on acceleration side of it. I want to see if the opportunities on acceleration, which is mainly on the side of the discovery, as well as what Massimo talked about, materials. Is that really acceleration opportunities is on the materials, or we also have acceleration through data in device level and system level as well?
I mean, I would say that this can be definitely a synergy, and those things can complement themselves, right? So if we're thinking about like AI for material science, for example, and then if you have materials that are being developed, and then you have a feedback of data to then go back, it's kind of this idea of like the AlphaFold from Google, for example, to identify potential avenues for new material science in this direction. So I do think that there is a acceleration possible where you have more data being generated, more data science being applied, and therefore those things that actually make everything go faster, go quicker.
Good. Yeah. So what I hear is that what you're explaining is that there's a lot of opportunities, of course, on material side, and maybe that's a good segue to go to Diego. I know he has been involved into several sort of data sources, data pipelines, sort of IoT, which I'm assuming is more towards the devices and systems. So maybe a little bit on discovery, on new paths of data pipelines on that end. Role of IoT to accelerate adoption of some of the technologies in respect to hybridization. Where do you see the acceleration is happening with those data pipelines, Diego?
Good morning. Good morning, and thanks for this opportunity that you give me to talk in this very interesting webinar. And of course, I'm talking about probably a topic that is cross-discipline, so cross-domain applications, because it's mainly related to the importance of data. So it's not strictly related to hydrogen or to storage technologies, but of course is related to all the fields in general, because of the importance of data and the importance of services that can extract from data the knowledge, can provide also new models and new business models depending on data. So the importance of data is quite recognized worldwide, because we know that from data we can extract knowledge and we can take decisions, we can plan other actions and so on. So at the European level, the concept of data space, for instance, is becoming more and more important. And here I'm going to represent in some way Enershare. This is a project co-funded by the European Commission that engineering, the company that here I'm representing, is coordinating. And in Enershare, we aim to build an energy data space at the European level. That means energy, so also storage, but also energy consumption, so also all the information and data related to electricity, to heat, and so on. So probably the main problem is that the companies or the entities that have data usually don't trust to give data or to share data with other subjects. So there are some barriers that do not allow entities to share data and to create a real data ecosystem. That is what we need in order to get those services, also based on artificial intelligence. I saw the importance of the artificial intelligence, machine learnings, and all these technologies that can process that and can extract useful information. So why data spaces, why this data coming from different sources, different data pipelining can be shared, and why who is the owner of data should share this data. Because now we have technologies that basically can provide trust, security, data sovereignty, can create real data ecosystems, and can work with the interoperability issues. So basically, trust is important because basically the owner of data, the data provider, should trust in the system in general. They must understand that the system allows them to keep the sovereignty on data. That means that you are the only subject that can decide about your data, the usage of data, from who will exploit the data, who will extract the data, who will use data. So data sovereignty, trust, security, that means that all the most recent technologies have been put in place in this software components, in this platform, these systems that allow people to protect the data that is the real value. Interoperability is another point because we have pipelines that bring data from different sources in different formats, from different models and so on. And this kind of technologies, the implementation of data space, allow also to manage this concept. So to put in place a real interoperability in the context of the data space that become a data ecosystem. That means that inside this ecosystem, we can build up on this data, new data-driven services, proper AI service able to process this data, and to create also new business model based on data, but in a secure way and in a protected environment for data consumer and data provider. So what a project like
so I'm just going to sorry, Diego, I'm just going to stop you there because I think what you're describing in terms of security and interoperability is important topic. I want to come back to you in the last round of the question to address that really well. So I want to close the topic of discovery aspects. I go back to Massimo if he has a few last words on that, if you want to add anything, and come back to a bit sector specific on hydrogen, and we come back to security and interoperability at the end. Massimo, do you have any last thoughts on discovery and where discovery has the best opportunity in this sector, and where do we have to focus? You are on mute.
Okay, so for what concern acceleration, for example, that is really the topic of this discussion. That the data sharing gives the opportunity to different labs, different expertise to work together and to manage different scales in the research. So, for example, computational labs can work with experimental labs, and with the help of artificial intelligence, they can quickly select new materials and test and find new solutions at all scales, so from atomic scale to systems and so on. So what we are discussing now is very, very important, and I am very proud to be part of the StoRIES project that is taking care of these aspects. So thank you.
Awesome, thanks. No, great. So I just want to close this. I think what I'm hearing is that the major opportunities, of course, on materials. I think it's a mature part of AI-driven sort of aspect of acceleration. But I hear that there's a lot of challenges on the system and device level that we have to get into to add that. So I'm going to go back to Benjamin a little bit on sector-specific hydrogen as sort of understanding what are, we know that hydrogen as a grid-scale storage has a lot of challenges. It has been used as off-grid, the power to gas, underground, overground, and and pipeline injection and all that has been used a lot. If you go to the sort of grid scale application of the hydrogen, it seems that to make it really a viable service opportunities, we need a lot of data to gather to see which services is really more viable economically, technologically, and interoperability of the whole process. Where do you think, in which area we already have sufficient sort of data to address these challenges, to add hydrogen into the grid scale services, anything from renewable firming to backup or storage, seasonal storage, and so on? And where do you think AI is going to play a role to make that available?
Yeah, I'm not sure AI will really help us make the data available. I would rather see AI as something that is important, like for data to be already available to then continue on, right? So if we think of connecting hydrogen storage in like an off-grid setting, in a laboratory setting, this is something that is somewhat easily realized compared to large-scale synchronous areas, right? I can't really connect this to the continental European grid and now experience and experiment with instabilities in the system. So what happens if I have a large outage or so? I can't do this in practice in the real system, but I can do this in a smaller scale system, or I have to rely on simulations. And I would say this is kind of one of the bottlenecks when it comes to data availability there, that if we want to roll out this technology on a large scale and integrate it into the existing large scale system, it should ideally couple to the existing large scale infrastructure on which we can't make experiments as easily and on which we don't have as much data available as I would at least like. So I would say that from an experimental point of view, for individual materials, you can record the data, you can share the data. I think this is an important part for the discovery of new material science. And if we now integrate it into the grid, we also need a lot of data from the grid side. And we have, for example, the ENSO8 transparency platform. So this is something very nice from the EU side, that there is already some transparency regulation that market participants have to share certain data about balancing power prices, generation, load, something like this, even for different zones. And I think we likely need more of this, more granular and higher time resolution as well. And so if we are talking about hydrogen balancing on scales of hours, days, I think we might already have good data for this available. If you want to use this also on shorter balancing timescales of, let's say, minutes, for example, then it's going to be much tougher to work with the data we currently have. So this is something where I would say on the grid side, we just need more data to really make this available and viable and integrate it into the system. So then say, okay, can we use AI, for example, to analyze the stability, analyze the capabilities of upscaling this, making forecasts on the grid scale for wind, solar, included with hydrogen storage and usage and as balancing power there.
Yeah, that's great. So what I'm hearing is that we, on the grid side, we have some data available, but integrating that into an AI pipeline or machine learning pipeline or MLOps, it's really important to sort of get the value out of those data on the grid side. So I want to go back to Diego a little bit on same topic of energy storage specific. It could be hydrogen, it could be other energy storage if you're familiar with in your program and similar. When we do hybridization in a grid scale or grid connected storage, such as hydrogen, let's say with flywheel or any other technologies at the renewable site or at the substations, we deal with different data on the grid side, as was mentioned, needed. But to what degree you think that the grid on the technology, the data on the technology itself is also important? Is that more coming from the vendors, from the technology vendors? Or is it more available at the site operations, or is it more available through the specific sort of data hubs that you have created or you will create? I just want to understand a little bit of granularity of the data for a hybrid system on a grid connected setup at the technology and the technology level all the way into sort of system level. What are those granularity? Do we have a gap on technology data? Do we have a gap on system level? So if you can address that a little bit, that would be very helpful.
Well, it's not so easy to answer to your question because it's a very complex question about where to invest in the direction and the right direction. I think that we should consider that the using data, processing data, and then extracting from data the required knowledge is something that must be concern all the stakeholders that are involved in the process. So data providers, at the system level, at the device level, and also software providers. So all the stakeholders should cooperate in order to go in the right direction of building proper data spaces and data ecosystems. So I cannot give you an answer like, okay, these are the subjects that should invest on that. I can tell you that as a European project, we are trying to develop softwares that can be adopted by who is owner of data, by who want to consume data, by who want to build services on top of data. And these technologies are there, can be deployed, tested, and so can bring benefits to the field, also in the context of hydrogen, also in the context of energy storage, whatever kind of energy storage we are considering. We had experiences with hydrogen. We created a plant for transforming surplus of renewable energy into hydrogen and then into methane. And in Puglia, we created a real plant that was, let's say, visited by a lot of people coming around the world. So we also experienced the importance of data coming from hydrogen plants and from storage, because there we also created physical hydrogen storage and physical methane storage. So even though our experiences are not mainly focused on this field, we had experience on that, and we experienced it also in this context, the different subjects that cooperate in order to create data, collect data, process data, and build services must cooperate, also investing in these technologies, because probably it's the future in terms of the importance of data in every kind of context, especially in the energy context, where really we need to fix a number of problems related to climate change and so on. So I think that all the subjects should invest on this, and technologies are there. So we need to simply adopt these technologies and make value starting from them.
Okay, well, great point, Diego. I think we would agree that the enterprise solutions are really out there. I mean, there's a lot of this already developed, but not well adopted or borrowed from those sectors to the energy sector in general, and energy storage. I just want to have a note to the audience. If you have any questions or anything, please put them in the Q&A. I'll get into that in a few minutes. So Massimo, do you want to add anything to this topic of the granularity of the data across value chain, and anything on your side that you think? I want to see if your point is more towards adopting AI to make it easier to monitor data across value chain. Where do you think the opportunities are for AI-driven data models or sort of AI-driven methodologies that could make this possible across value chain? Any quick feedback on that?
I think that it's a great time now. We have a lot of opportunities. There are platforms, for example, that can easily give access to the data. There are technologies to make data available and on common formats. So I think the opportunities are there. Also, not only for the research labs, but also for enterprises, as we have already heard. So let's discuss of this and move forward.
Sure, awesome. So what I heard so far on this is that we really have to look at already established and developed enterprise solutions, really bring that into the sector. So that's why I want to just alluding to the last part of our conversation, and I want to really go to Diego because he mentioned a lot about interoperability, sort of partner access and things related to security. We talk about requirements and what we need. We didn't talk about how we do it. And I think one of the things that Diego is involved in terms of knowledge exchange across the different data space, European data space and programs. Maybe we can talk a little bit about the success of those initiatives, how really joining an energy data space in general beneficial to sector of energy storage that we are discussing today, and where do you think the gaps and opportunities are to address that by joining that? Maybe a little bit more into adding more partners. Where do you think the gaps are in terms of the building a strong ecosystem of the data? Diego?
Well, of course, as I told you, there are technologies that can help in these, but are not widely adopted at the moment. So there is the need to overcome some barriers about that. You mentioned security. You mentioned interoperability. Let me do an example. There are several different architecture for data spaces, but if I refer to one of the most well-known, like International Data Space Association, this kind of architecture consider at least two levels of security. We have an identity provider that ensure the identity of each single stakeholder that is involved in the process. So in some way, allow the access to data only to people that are authorized to do that. But there is also another level of security, like to control usage or usage control. That means once that you establish a sort of agreement between the data provider and the data consumer, it's also a contract. This contract foresees that you can use data for a certain aim. So this technology is put in place so that this can be ensured by technology. That means if I give you access to my data to do something, you cannot do something different. So once that this technology is ready, this technology can be deployed. Data consumer and data provider, especially data provider and data owner, should understand that their data are protected and that usage of this data is not out of control, is controlled by technology. We also put in place some solutions, for instance, by means of blockchain that should let's say, store all the transactions and which data consumer want to access to data provider in order to process some kind of data. So all these technologies are there and are useful to ensure security and to ensure that data are always protected and sovereignty and governance of data is ensured to the data owner and data providers. Also about interoperability.
Sure. Just on that point, assuming I'm presuming I'm a sort of energy storage vendor, developer, I don't have expertise in data or protocols that you mentioned. Is your open space European program you're involved is giving any access to those sort of tools and expertise, or at least understanding what requirements, or do you think there are other sort of avenues has to be developed to give to the vendors who are not necessarily data experts or data owners to understand the existing tools, existing platforms, and also those protocols and requirements? Specifically, is that your program supporting anything like this?
When you say program, you mean project?
Yeah, the project, the open space.
Yes, of course, the projects on data space, NSHare is one example of project on data space, because there are many other projects on data space. And I suppose that vendors, as well as owners of data and data provider, can access on the web. You will find a lot of things. Of course, you can start from us, that we can have the contact to all this technology that is already available, just to test and try to understand how it works, and if this ensure the minimum set of requirements to make this data transfer and data processing possible. So I cannot say that we are the expert in that, but we are in this application domain. We are working on that. We have several projects that manage the data spaces. And In terms of engineering, that is the company that I'm representing, we have developed a special component that is called the True Connector. The True Connector is the basic element of the data space because it ensures a set of functionalities, including security, data sovereignty, data governance, and so on, that can allow to two different subjects to exchange data in the context of a data space by means of two instances of connectors. So this connector is probably the most certified one in terms of coherence according to a specific reference architecture, standard architecture. So also in this, we can say that we are able to provide technologies as a company, as a project, as a part of a research area in which data space is one of the main topic that we are addressing.
Okay, great. So I think what I'm concluding on all this discussion is the availability of the tools and means that we don't have to reinvent the wheel when it comes to data space and AI connected. So Benjamin, do you want to add anything to that as well before we wrap up?
I think only that I would second Diego's idea of safety and making sure that the data owner knows that no harm comes to them and their data. I think this is an important point of establishing trust so that we transition more to an open community where people are not afraid to share the data in secure ways, so that we from a research perspective, but also from an industry perspective, actually can work very, very well together and actually generate synergies there. Yeah, so.
Awesome. Okay, great. So I'm just going to wrap up the whole discussion across all these questions in terms of the acceleration. I heard a lot that materials has a great opportunity to adopt AI methods. The other part of the value chain, the system level, device level, also has potential. I think is at the earliest stage of adopting those technologies. In terms of grid connected hybridization, it seems that the grid side data is very valuable if it's widely available. And of course, the interoperability of the data and all that is important. And of course, in terms of security, data ownership, following things that are already done in different projects, as Diego has pointed out, is very useful. So we might have a few more minutes for any question from audience. I don't see anything on Q&A at this point. Is there any question that you want to add into this? If not, I guess I just wanted to thank three of you for joining our discussion today. Very valuable inputs into the space that we are, and I think we hope that the discussion was useful for the audience to build on and hopefully solve some of the challenges that they have as they develop the technology and the research. Thank you. Myriam, back to you.
Yeah, thank you very much, Kourosh, and all the speakers of the second session. So I am supposed also to wrap up what was discussed today, but it's already too late. So I just wanted to underline what was mentioned at the beginning. We have to keep in mind that the future energy system will be much more decentralized, disaggregated, and multi-vector, and therefore there is no single silver bullet solution. Instead, we need the combination of the different technologies. We need to develop new hybrid energy storage systems to face all these challenges, as was shown in the different projects presented at the beginning of this webinar, for example, on batteries or thermal storage. It is also true that artificial intelligence will play a crucial role in accelerating the development of new or advanced materials that will be needed in such kind of hybrid system. And also we need to continue working on data management, machine learning, interoperability, and moreover, as we have here, creating and sharing energy data spaces if we want to be able to decarbonize Europe by 2050. So with this, we are coming to the end. I would like to thank to all speakers again, as well as the moderators of the different sessions, Philippe Stevens and Kourosh Malek. and especially to Spiridon Pantelis from ERA and also Work Package 1, leader of the StoRIES project, for the preparation and the great organization of this webinar. And I don't see any other question. With this, I wish you all a nice day. Thank you and goodbye.
Thank you.